All right, folks, let's get started. Welcome to today's weekly Planette webinar, where we talk about all of the factors that affect the long-range weather outlook on our changing planet. So today we're going to be speaking specifically about the hydrologic cycle and related volatility, specifically about drought, deluge, or both, which is often the answer. So my name is Dr. Hansi Singh. I am founder and CEO of Planette AI. I'm an Earth system scientist. I have a PhD in atmospheric sciences, and I previously worked at the US Department of Energy as well as in academia as a professor. I decided to start Planette because I really wanted to create a way for funneling the type of information that was sort of stuck in research circles into the real world to help people make decisions that mattered for them and for their businesses. So today, specifically, water is life, and we're going to talk about how the hydrologic cycle is changing on our warming planet and what it means for the long range outlook. So first, we're going to talk about elements of hydrologic cycle change, specifically, does it get wetter? Does it get drier? Or is the answer both? And how is the hydrologic cycle specifically intensifying? Then we'll talk a bit about implications for particular industries and specifically commodities. We'll hit on supply chains, manufacturing, hydropower, and mining. And then we'll move a bit into what long range forecasts can tell us about hydrologic cycle volatility as we are undergoing these much longer term changes over the next decades. And then we'll look at some tidbits of the outlook over the next 6 months, specifically over Asia, South America, and Europe. So, the hydrologic cycle is intensifying. And to understand this intensification, it is helpful to think of one fundamental number. And this fundamental magic number is 7%. 7% of intent, like 7% increase per degree Celsius of warming. So this is derivable from fundamental thermodynamics. It's not, I do call it a magic number, but it's not magical. It's scientific. And it basically describes how much extra water vapor the air holds for every extra degree of warming. And so that number is 7%. And this describes how the hydrologic cycle intensifies. So many areas around the globe are getting wetter. So even though the hydrologic cycle is intensifying at around 7% per degree Celsius of warming, um, globally precipitation is increasing around 3 to 4% per degree of warming, which is actually, it's due to some fundamental physics as well, limitations in the rate that the atmosphere can cool. So luckily, precipitation is not increasing at 7%. We might be in even greater trouble if that were the case. But many regions are getting wetter. And in some cases, this might be really good. So the tropics, certain areas in the tropics are getting wetter. This includes many areas in Asia in particular, and Central Africa. Then the mid latitudes. So kind of you can see the mid latitudes here over the US, Northern Europe. And then also the high latitudes in both hemispheres are getting wetter. So in these regions, the change in the water balance is positive, which means that the amount of increase in precipitation is not necessarily being exceeded by the amount that evaporation is also increasing. So these regions are going to have more water available if you are able to, prevent it from running off or causing devastation and havoc in other ways. However, there are major regions that are going to be much more prone to drought. So these regions are shown in orange on this global map here, which is from the IPCC. So what does drought mean? It means less precipitation, more evaporation and transpiration from the surface, and more runoff through rivers. So, regions that are drying include South Africa as well as regions in West Africa, right? And remember, there's some pretty water intense industries here. So, yeah, that might be something to keep in mind. The whole Mediterranean is drying. This is very robust in our models, and it is definitely something to plan for, specifically when it comes to hydropower. Mexico, Central America, and most of South America, other than Argentina, are drying. And then portions of Australia as well, some of which also have water intensive industries. A major area where net drought is, it's not clear if these areas are going to dry in net, are the American West and Southwest. And so there's been a lot of literature written on this, and we don't quite know which way this region is going to fall. But it is something I think to keep track of because there is so much uncertainty, particularly in that area. So, at the same time that drought is increasing in many parts of the world, precipitation in many other parts of the world is becoming much more intense. And in fact, remember we said 7% is the magic number? Well, in many parts of the world, precipitation intensity is increasing at greater than 7% per degree of warming. So, what does this mean? It means that the distribution of the probable maximum precipitation over many parts of the world is trending upwards. And it's going to continue to trend upwards as our globe continues to warm until we figure out how to achieve net zero. Precipitation is intensifying at all temporal levels. So this is like at minutes, at hours, at days. So this means that in general, precipitation is becoming concentrated in fewer, much more intense events. So you're getting a lot of rain, but sporadically in these extremely intensive storm systems. And this brings us to storms. So, storms are changing around the world. And so, right here is kind of the precipitation story. Cyclones, so hurricanes in our part of the world, type or typhoons, you could say, those are becoming are the precipitation rate in those storms is increasing with warming. Those storms are just becoming more juicy. Extratropical cyclones, same story. Atmospheric rivers, same story. In general, storms are now carrying even more water vapor, and so your average and your maximum precipitation rates are increasing. The story about the actual intensity of storms, particularly when it comes to winds, that's a little bit more of a mixed bag. So, when it comes to tropical cyclones, they seem to be increasing in strength. So, it's sort of more likely that they are, achieving the higher categories. At the same time, it is possible that maybe their frequency of being created, their genesis, is actually decreasing. Though this is an area where, once again, it's an area of scientific disagreement and major study. We just don't quite have enough scientific consensus to say for sure at this stage. And then when it comes to mid-latitude storm systems, we know that they're shifting poleward. And in some cases, it appears that the wind speeds are increasing, some cases decreasing. So it's a bit more of a mixed bag there. And then when we look regionally, and this will be an area where we will definitely do another webinar. This is about severe convective storms. So in the US, the season for severe convective storms is getting longer. And specifically because these convective storms are juicier, we are seeing an increase in the severity of hail. So essentially, these updrafts that go up into major thunderstorms are getting more filled with water vapor. And as they become more filled with water vapor, the hailstones that form in those updrafts are becoming bigger and bigger and bigger. And hence, hail damage is increasing, as many folks know. In terms of tropical cyclones, this is actually really interesting to me over here. So, you can actually see that there's this kind of northward shift in where tropical cyclone landfall is likely to be. And so, the poor Philippines, which has just been hammered this year, we actually expect some decreased exposure there in the long term. And then we expect more exposure for China, Hong Kong, and Japan in the future. So now that we've looked at storms and precipitation intensification, let's think about the dry season as well. So, in general, even in regions where we see an increase in precipitation, many of these regions also see a lengthening of the dry season. So, this is one of those areas where the right answer is not drought or deluge, it's actually both. So, the length of the dry season is increasing in that the number of consecutive dry days is becoming greater. Runoff is also happening earlier in the year. So by the end of the dry season, we're often in a period of water stress. Soil moisture is decreasing much more rapidly through the course of the dry season, which impacts agriculture. And finally, vegetation dries, and this serves as excellent flammable fuel for wildfires during this longer dry season, particularly to the middle and the end. And so the side effect here is just rising wildfire vulnerability linked to this lengthening of the dry season. And you can see here, this shows kind of what this map of this rising vulnerability looks like in terms of fire weather season length. And you can see that as our globe continues to warm, this is going to become more and more and more of a problem. So more vegetation growth during a nice wet season combined with warmer temperatures during this much longer dry season means that pretty much everywhere on the globe, we see an increase in fire weather days. So this is a direct impact of how our hydrologic cycle is changing as our planet warms. So there are a ton of industries to watch here. So first of all, it's really important to think about how this drying impacts transportation and logistics in particular. So droughts are becoming increasingly common in many parts of the world. And one of these regions is Central America, and Central America has this really important transport region, which is the Panama Canal. And the Panama Canal is essentially the locks in the canal depend on fresh water. Fresh water comes from a single or a couple of reservoirs, one of which is Lake Gatun. And the levels in this lake are highly prone to drought. In fact, we've seen periods already where transport through the canal has been impacted by droughts. And the writing is on the wall that this region is going to see more and more droughts in the future. Keep in mind that 5% of global shipping happens through the Panama Canal, and that a single week of disruption of transport through the canal decreases GDP by $1.5 billion. So this is pretty significant, and hopefully there are some adaptive measures for thinking about how goods can travel from the Pacific to the Atlantic, given the sensitivity of this particular transport pathway to drought that we know is on the way. Another major industry to watch is manufacturing, particularly when it comes to manufacturing centers in Asia. So many of these regions are now increasingly prone to flooding and landslides linked to extreme precipitation. So, for example, in 2011, there was major flooding near Bangkok that resulted in about $40 billion in losses. And in fact, decreased global GDP growth that year by over 1%. So, in other words, a single series of major storms over this very sensitive region led to major global impacts, specifically in automobile manufacturing, hard drives, and electronics. So, this, for example, is an image from the Honda manufacturing lot in 2011. So yeah, cars underwater, and in fact, apparently, it was even worse at Toyota. So if you think about Toyota, you see this kind of huge dip in some of their financial figures in 2011 and going forward for a few years after that due to this event. And currently, this is a region that 2025 right now has been subject to an insane amount of precipitation with landslides, with flooding. So this is actually a story that has sort of just emerged and something to continue to follow in terms of impacts on manufacturing that we will likely see downstream as the impacts of this current event unfold. Another industry to really watch is hydropower. So this figure shows the per capita electricity generation from hydropower. And notice that there's a couple of these regions that receive a lot of energy from hydropower per capita that are very vulnerable to drought. So this includes many parts of South America, and this includes many parts of Europe, specifically the Mediterranean. And so, given the fact that the writing is on the wall that these regions are going to be increasingly prone to drought in the future, it is really important to think about what kind of energy transitioning happens in these regions to ensure that the energy and power needs of folks here are going to continue to be met. So this is a major industry to watch. And just keep in mind, hydropower is still an industry that continues to grow. There's a ton of new dams that are constantly being financed and built. And hopefully people are really considering how the hydrologic cycle is changing when they figure out how to situate these dams, because there's some areas where it is likely not a great investment. And another industry to really think about is mining, specifically when it comes to, for example, South America. So South America is drying. Mining, many types of mining are water intensive. Obviously, you don't want a deluge, but you do want enough water to be able to process ore, keep down dust, etc. And so South America is going to continue to be at increased risk of drought into the future. And so, water scarcity is going to be something that mines in this region are going to need to plan for, as well as increased fire weather, which is likely also going to happen. Some other regions are also at risk in terms of mining. One is, of course, Southeast Asia, where we've seen a lot of mine catastrophes and failures, specifically linked to extreme rainfall. Definitely something to keep in mind. And then in other regions, like say Central Africa, where there's a ton of mining, there's kind of this combination. Some areas, extreme rainfall is a real risk. And in other areas, particularly in West Africa, there is the possibility of water stress creeping in and impacting mine productivity. So, just some factors to keep in mind in terms of thinking about how mining is going to be changing over the coming decades. So now let's take a look at the long range forecasts and what they potentially can tell us about water cycle vulnerability over the next few months. So, first of all, just a really brief overview of what long range weather forecasting is. So, your usual weather app, which can predict the future up to 14 days, is run through what is fundamentally an atmospheric model. The atmosphere generally forgets where it started from after 2 weeks, which is why these models are limited to about 14 days of skill. And so, in order to predict beyond that, we need to look at other elements of the Earth system that have a much longer memory. And so, this includes the ocean, the ice, the land. And so these Earth system models that we run in order to think about anything in the climate system beyond 14 days, they are much more complex models, and they take advantage of the fact that, for example, the ocean has decades to centuries of memory. And by using these other components of the Earth system, we're able to get insights onto how the weather is going to evolve weeks to months to even years into the future. So, in terms of hydrologic cycle volatility, long-range forecasts have some superpowers, but they also have their kryptonite. So, in terms of superpowers, they are quite good at predicting persistent anomalies, either on the wet side or the dry side, in the tropics, the subtropics, and the mid-latitudes with weeks or months of lead time. So what they're very good at is predicting intense monsoons and each actually in terms of monsoons as well, like they're quite good at even determining kind of what week the monsoon is likely to start. So timing as well, in addition to intensity. They are also good at telling you, is this going to be a really active and rainy mid-latitude storm track? They will tell you a lot about the likelihood of meteorological droughts, and they'll tell you about active hurricane seasons. One thing to really remember is that individual precipitation events, like say the exact location of hurricane landfall or exactly where hurricane genesis is going to happen, yeah, that is something that these types of forecasts can't do. So one thing I always like to say is like, well, we can tell you the likelihood that it is going to snow at your location in around Christmas time, but we can't actually tell you will it snow at your location on Christmas Day? So, in other words, individual events cannot be predicted, but sort of overall fundamentals of whether we are looking kind of on the wet side or the dry side is something that these forecasts do very well. So, let's look at a few tidbits of the long range forecast. So today, one thing that we actually have been talking about for quite some time at these webinars is the outlook for rainfall in Europe. So in general, one thing that we're seeing is that Southern and Eastern Europe look pretty dry going into this winter and this coming spring. So yeah, we've mentioned this before, and so you might want to think about this in the context of a few things. Of course, hydropower, right? So these are actually areas that have a lot of hydropower facilities, surprisingly. And so definitely something to keep in mind. Also, transportation. Many of these locations use rivers for transportations, and if river for transportation, and so if river water levels are low, this actually impacts logistics for goods. And then tourism. I am going to wager that this potentially is going to be not a great wildfire season in this region. And so definitely something to keep in mind. And I'm sure, tourists figure these things out. And so definitely we may see some depression in the tourism sector. And then, of course, any manufacturing that happens in this region, there is the potential for water stress. The South American outlook is super interesting as well. And particularly over Colombia and over the Colombian highlands, where a ton of coffee is grown, specifically Arabica, which is the sort of premium coffee that those of us that, for example, live in Seattle and love our lattes, like to partake in. And so, in particular, this region is looking intensely wet over weeks and months. And that wetness, it has in fact already persisted over the last couple of months. And so this is an area where it is like, at this point, given the fact that coffee likes rain, but not too much rain, we're almost certainly going to see yield impacts in this region. Specifically, the effects of that intense rainfall and then the knock-on effects of that, which include disease. Often in the tropics, in particular, when there's too much rainfall, many plants can succumb to various types of fungal and other diseases. And so this likely is going to have an impact on yields. So definitely a region and related agricultural effects on this region to keep an eye on into the next couple months. And then finally, I just wanted to touch on the outlook over Southeast Asia. So this region has just been pummeled, just pummeled recently over the last several months. And so, I just wanted to kind of take a look at the forecast in this region and say, hey, how does it look for these folks? And in fact, thankfully, it looks a little bit closer to normal than it has looked over the last several months or last couple of months. And so, thank goodness, hopefully, that there is, rebuilding and some restoration going on in these regions following just a really difficult monsoon wet season. Another thing you might have noticed as this video was playing that there was also next week in particular looks like some really heavy rain in South India. So in South India in particular, they sort of have two monsoons. And so this December monsoon is really kind of creeping up and it looks like it's going to be around next week. So just a little tidbit that may potentially impact transportation and industries in that region. So thank you all so much. We will be back next week for the next webinar. And in that webinar, we'll look particularly at the events of 2013 to 2016 to help us understand a little bit about what to expect in 2026. So thank you for being here. If you're interested in learning more about what we particularly do in the area of long range forecasting, you can reach out to me, Hansi at planette.ai. You can find me on LinkedIn. You can find us at our website. And yeah, you can get in touch because we would love to chat with you and tell you more about, what are the superpowers of a good forecast. And yeah, it's not magic, so it can't do everything, but maybe it can help. And finally, we're approaching the holidays. We do have a webinar next week, but we will be out for a couple of weeks over the holidays. And so if you are getting Planette webinar withdrawal, we always have a YouTube channel that is available to you all the time. And this QR code will take you right to it. So yeah, would love to see you on there. And we'll keep an eye on comments and anything, or feel free to email us with any questions. And of course, we're always looking for suggestions for upcoming webinars. So please make your suggestions at any time. And now I'll spend the next couple of minutes answering any questions that folks have. Okay, so there is a question. How can we leverage these powerful insights to inform decisions, policies, changes at regional and global scales, given that regional weather is also influenced by global behavior patterns? Um, yeah, so Pranati, are you speaking particularly regarding the fact that the atmosphere is sort of common to all of us? And so yeah, I'd love to hear a little bit about sort of like are you thinking about kind of the global warming context in particular?
Hi, Dr. Hansi. Yes, I was thinking more along the lines of how do we motivate more decisions on a policy scale or a governmental scale, given that there's both regional and global impact. Not everyone wants to listen to the global impact when writing down the policies that can make things better. So you've mentioned a lot of industries that are getting impacted and the monetary value associated with them to help motivate folks. So I think what I was trying to understand is how do we, motivate people in one region of the world to improve their policies, not just for their citizens, but the fact that their behavior indirectly impacts someone else in a completely other region.
Yeah, this is one of the challenges of basically everything related to climate, right? Because, for example, an area that this is such a huge issue is when we start thinking about geoengineering. and specifically using geoengineering techniques to try to sort of blunt the effects of climate change, which we've shown are, as you said, like substantial around the world across industries, right? But then, yeah, like, oh, well, I just put these, aerosols into the stratosphere and suddenly I've suppressed the Asian monsoon. Right? So sure, maybe, the globe is a little bit cooler, but, people are suffering now in other ways, right? And so, yeah, it is such a challenge. I do think that the fact that pretty much every country in the world is going to be impacted, I think that that hopefully results in some kind of, will for collective action because it's not one of those things where some countries, in terms of climate change in particular, like some countries are just going to, get off scot-free. I just don't think that that is the case. For example, I think there's often been this thing about like, oh, well, Canada and Russia, it'll be great for them. And then I think we've seen with the wildfire seasons, right? Like it is not great. It is not great at all when you have like huge swaths of your country burning and everyone is angry that, like the air quality is horrible, right? I mean, in the eastern US, this has become an issue because the Canadian wildfire smoke is like destroying everyone's lungs every summer, right? So I just think that that interconnection is, yeah, it is a problem, but it is also to some extent like fortunate because that means that we're all in this together, right?
Yes.
Yeah. And I wish I knew the answer to like how do we motivate people to act because I feel like maybe then we wouldn't be here right now being like, please use this information because like things are, yeah, they're getting real, folks. Yeah.
Thank you.
Yeah, thank you. Are there any other questions? Thank you, Darius, for your feedback. All right. Thank you all so much. And you know where to find us. And we look forward to keeping in touch and hope to see you next week.